So please,
Okay, can I share screen now?
yes, please.
Okay.
And introduce yourself before
Okay.
you.
Okay. Can you see my screen now?
Yes, fighting COVID-19.
Okay.
Yes.
Okay.
And please share the slideshow. Okay.
Wait.
Okay.
So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Haekal Rizky Yulianto, and today we would like to present our paper titled Fighting COVID-19 Convolutional Neural Network for Elevator User Speech Classification in Bahasa Indonesia, which is an undergraduate thesis supervised by my lecturer, Mrs. Afiahayati. So here is the outline for this slide, which consists of 6 parts. First, the introduction of this research. As we have known that COVID-19 is a global pandemic, that respiratory droplets are one of the main ways the virus spreads among people. The elevator button, as a public facility inside the elevator, may become a medium for virus spread by physical contact. Fortunately, research in audio classification have developed well, including the research conducted by An Mohamed, states that since 3 decades ago, male frequency spectral coefficient, or MFCC audio feature, has become the state-of-the-art for audio feature extraction due to the accuracy provided from that method. Later on, Hamid et al. States that male frequency spectral coefficient, or MFSC, is more suitable to neural network model since it is more correlated and local compared to MFCC and suggests to combine it with its dynamic features. Then Wang, Li, and Gong provided analysis on deep neural network and convolutional neural network model that concludes that CNN is more robust compared to DNN in terms of noise robustness and distant speech recognition. As of the first week of November 2020, when this research was proposed, there were around 400,000 COVID-19 cases in Indonesia. Now, as of the 1st June of 2021, there are 1.8 million cases in Indonesia. This is worsened by the existence of community activities despite the pandemic status that may cause several public facilities, such as elevators button, becomes a medium for virus spread. As a first step to overcome this problem, a classifier model that is able to classify spoken utterance from elevator users is needed. Several, several objectives for this research are to create spoken floor numbers and comments data, develop a classifier model, and evaluate the performance of different audio feature extraction methods with different classifier models. The dataset for this research are gathered from 10 persons, each of them speak for 10 audio classes, 1 until 6, buka, tutup, naik, and turun, which are number 1 until 6, open, close, up, and down in English. Audio feature, namely MFCC and MFSC, alongside their dynamic features, are used for the input of the CNN and MLP model. Hopefully, the spoken floor numbers and comments data in Bahasa Indonesia could be further used and expanded by other researchers in need, and the classifier model could be further implemented on a microcontroller, which is then later installed on the elevator. Next, the literature review for this research. So 11 literature from research and journal have been reviewed to understand the fundamental theorems of audio classification, especially about feature extraction and audio data classification methods. Starting from environmental sound, continuous speech, disastric speech, and several isolated word of utterances data from various languages. This research would be different from the previous one. Despite the last two research conduct research using Indonesian digit utterance, however, spoken digit data is not suitable for this research, as most elevator numbering in Indonesia doesn't include zero, and some additional comments are utilized to go up or down and to open or close the elevator door, which adds to the variety of the data. Now, a brief explanation of the theory used in this research. So, male frequency spectral coefficient, or MFSC, is obtained from the red and green box flow diagram, while the male frequency spectral coefficient is obtained from the red and blue diagram. The main difference between MFSC and MFCC is that the MFSC features are produced from the log of male scale filter instead of taking discrete cosine transform or DCT that produce decorrelated features. Additional dynamic features, namely delta and double delta, are computed from obtained male spectrum and male substrum features. CNN is known as shift invariant or space invariant artificial neural network, which allows CNN to detect features even if it doesn't look the same in the training process. This architecture is composed of three kinds of layers, namely convolution layer, pooling layer, and fully connected layer. The convolution layer and pooling layer are mainly used to extract features, while the fully connected layer is used to classify the flattened shape of data from previous layers. Now for the design and implementation. Here is the brief workflow of the research conducted. So there are 10 classes of utterances that consist of spoken floor numbers from 1 until 6 and spoken commands to go up or down and to open or close the elevator door, namely naik, turun, buka, and tutup. This table gives an overview of the class label of the dataset as well as English text equivalent information. Audio data used in this research are gathered by using the Google Form questionnaire that receives audio files from 10 participants. Isolated word of audio data of utterance are collected from 10 persons, 5 females and 5 males, with each of them speak 10 different speech styles or pronunciation for every 10 classes, which totaling 100 audio data from each person. All audio files are recorded using various audio recorder with various audio formats. For example, MP3, M4A, WAV or WAV, and AAC in the various sample rates and various duration in a non-soundproof room. In order to uniform each audio format to WAV or WAV, an audio duration to 1 second with 16 kHz sample rate, an audio software editor named Audacity is used. At first, each utterance is uniform in terms of duration to 1 second, then sampled to 16 kHz and windowed with 25 millisecond size of Hamming windows for every 10 millisecond, which produces 99 frames. And then 13 MFCC and MFSC coefficient are extracted using the Mel scale filter. It will return two-dimensional feature maps of two-dimensional feature maps of frames and MFCC or MFSC coefficient. Then dynamic features are then computed from the static MFCC and MFSC features and represented as additional feature maps. After that, those dynamic features are then arranged in the depth axis. So each utterance is going to be represented as a 99 times 13 times 3 feature, since each feature map has a size of 99 times 30. The CNN architecture used in this research consists of an input layer, one convolution layer, 16 3 by 3 filter, one pooling layer utilizing max pooling, one fully connected layers with dropout to avoid overfitting, and an output layer. ReLU activation function is used on convolution and pooling layers, while the softmax activation function is used on the output layer. Additionally, categorical cross entropy loss function and Adam optimizer is going to be utilized to compute the loss and to optimize the model. Multilayer perceptron is also compared to the CNN model to analyze the effects of additional feature extraction layers that exist on the CNN. The MLP architectures consists of an input layer, one hidden layers, and an output layer with similar activation, loss, and optimizer function used on the CNN. So there are 1,000 data in total, with 800 of the data are used for training and validation, while the rest of 200 data are used for testing. Before the learning begins, audio files in train and validation are split into five-fold cross-validation to ensure that every variation of data has a chance of happening. Then the classification accuracy is used as matrix together with the confusion matrix to analyze in which class the model confused to classify. Now for the results and discussion. So first of all, to determine the best performing configuration of CNN and MLP, the experiments on the following hyperparameters were conducted sequentially and see the effect of varying hyperparameters on the classification accuracy. The first experiment used the baseline CNN model configuration, which results in 81.7% and 84.62% of train and validation accuracy. Audio feature is chosen initially based on highest accuracy achieved, but will be shown again after all hyperparameters have been optimized. It turns out that 5 by 13 filter size provides better train and validation accuracy, which is a one-dimensional convolution process. One filter strike is still the optimal value. Adding more filter after 18 stabilized at around 85 and 87 train and validation accuracy. And average pooling provides better train and validation accuracy ratio. 2 by 2 pooling size is still the optimal value. 128 neurons is still the optimal value. As increasing more neurons, it starts to overfit. 0.5 dropout rate is still the optimal value. Adding more EPO after 30 only increased the train accuracy but not the validation accuracy. Optimizing parameters on CNN does increase the train and validation accuracy by around 10% and 6% respectively. Same optimization treatment for MLP model. The first experiment used the baseline MLP model configuration, which results in 76% and 72% train and validation accuracy. Audio feature is chosen initially based on highest accuracy achieved, but will be shown again after all hyperparameters have been optimized. Adding more neurons after 192 only increased the train accuracy but not the validation accuracy. 0.5 dropout rate is still the optimal value. 50 epochs provide stable strain and validation accuracy ratio. And then optimizing parameters on MLP does increase the train and validation accuracy by around 8%. After that, we evaluate on the test data. Both MFSC and MFCC audio feature performs a quite decent performance with small accuracy difference in both CNN and MLP model. But still, MFSC is able to perform better than MFCC, proven with consistently better accuracy provided. It can also be seen here that the feature extraction layer on CNN does its job very well in distinguishing different audio classes compared to MLP. Lastly, for the conclusions and suggestions, this audio dataset of spoken floor numbers and comments can be classified by simple CNN and MLP architecture with decent accuracy after obtaining optimal parameters with several key points mentioned here. MFSC audio feature performs better than MFCC with slight difference, while CNN gives a better accuracy compared to MLP. For the suggestions, in order to obtain a new outcome and findings, a larger collection of audio data collection of audio data from more persons and with more audio classes with various pronunciation should be developed to recognize a wider variety of speech styles and speech commands. Further architecture configuration with deeper or more layer to see the effect of deeper layer configuration on the classification accuracy, and also Other machine learning models should also be implemented. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Alaikum assalam wa rahmatullahi wa barakatuh, Dr. Haekal, and we can take one question because the time is
Yes.
almost. So any question from the audience? Any question, please? Okay. Thank you very much. We will switch to the next one, which is combining text and images for film age appropriateness classification by An Haa and Emad Mohamed.
Yes. Hello, everybody. Good morning, good afternoon, good evening. Can everybody hear me well?
Yes, you can share your slide.
Okay, how do I share my share screen? Yes, now I share my screen. Share. So, I hope my co-author Emad Mohamed can join, but regardless.
I'm here and I'm joining.
Oh, great. So this is a joint work between myself and Emad Mohamed. And we are from the research group in computational linguistics research institute in information and language processing, University of Wolverhampton. And we like to report our study on combining text and image for film age appropriateness classification. Our motivation for this study is actually both myself and Imad. We both have young children. And from time to time, they ask us, why can we not see the film? And we answer them, because it's not appropriate for your age. And they ask us, who got to decide what appropriate or not? And we think, okay, who actually got to decide is a board of faceless people sitting in some dark room and say, this film is appropriate for 12 and that film is appropriate for 15. And we were thinking, if we can design a computational model to provide the film, to classify the film appropriateness, then the children would be happier, because these days they trust the computer more than they trust the adults. So that's the motivation of our study. Eventually, this is what we want to do. Taking input a film like Breha, we process it, and then we suggest, so this film should have the rating of R. Or we take another film like A Beautiful Mind, and then we process it, and we produce a suggestion rating of PG-13. So in the work, there's a lot of film rating system. In this speaking work, there's a lot of data for the US and for the UK, and that's why we use both. We use the US rating and the UK rating for our experiment. In the US, they rate the film into general audience, parental guidance, parental PG-13, restricted, and no one NC-17. So the rating increase the appropriateness of the film from everybody to something that may not suitable for young children, not suitable for preteen. Parents is strongly encouraged to watch the film before decide whether to let the children watch the film, and there absolutely no one under 17 should be admitted. In the UK, there's a similar rating system from U, which is suitable for all, PC, with the unit parental guidance, 12, and 12A for only suitable for children of 12 years old or older, and then 15, 18, and R18. So in order to build a system that capable of automatically suggest the rating, we need to collect the data. So the film of the film, so in the film we will have the film script and the visual aspect of the film. And that's why we collect the data from 3 different sources that represent the aspect of the film script, the certificate, and the photo. The film script we collect it from the Springfield website, and unluckily, this website has been taken offline. But yes, we have collect about 17,000 film script in our data set. And then we collect the certificate. And thanks to IMDb, the IMDb already did the work for us. And we, for each of the title, each of the film, IMDb store all the certification from all the country they can have. For example, in this example, we have the certification, main certification for MPAA, and then certification for different countries from Argentina, Australia, Belgium, Germany, Spain, United Kingdom, and so on. And then we want to collect the visual aspect of the film. Ideally, what we like to do is to process the whole film, the whole videos, and then process the whole video, extract image from all the video. But we don't have the our collection. We don't have that. Our DVD collection is not that big, so we cannot do that. Instead, we rely on IMDb again, and on IMDb for each of the film, they have a set of image, including the image that have been extracted from the film, but also the image that relate to the promotion of the film. So in this case, we have this image, most of the image on the first few rows from the actual film, and then we have the image of the actor who go around and promote the film, and then we have the image of the film, the promotional material of the film. So that's where we get our data and why we get the data. So the film script contains most of the content of the film, but and then text alone may not carry the whole right or correct message. So we need to add image, and this example will show you. So in this example, if you have the text alone, then most of people would feel what is this about. But and then when we have the image, the meaning of the intended meaning become slightly clearer what they mean by self. So after we got our data set, we divide it into train, test, and development. And the train, test, and development have been split traditionally like in the literature, 70% for training, 20% for testing, and 10% for development. And the selection have been based on the stratified random selection by year of production. By year is because the reason why we're using year is it because if there's some subtle shift in perceive the appropriateness across the year, then using the selection by year, we reduce that effect. So for the image, I said before, we rely on IMDb and have a resume for each of the Each of the title, we don't have a lot of image. On average, we have from 38 to 72 image per title for the US rating. And for the UK rating, we have from 43 to 82. And exclude the R18, where we only have 2 images per title. And there's so IMDb, they refrain from putting ADU related image on the website, and that's why for the category certificate of NC17 and R18, there's not a lot of image compared to other certificate. For evaluation, we use the traditional accuracy and relaxed accuracy. Relaxed accuracy, we define it as a certificate that either the same or only one A rating higher or lower of the two certificates, and now will be considered correct. And why we use such relaxed accuracy? Because this is also a popular evaluation metric used in classification. We also use the area under the curve, and the area under the curve of the receiver operating curve. So the receiver operating characteristic curve represent the relation between sensitivity and specificity across different decision thresholds, and the area measure the whole two-dimension area underneath the entire curve from 0, 0 to 100% to 100%. So the area under the curve give us some idea about the trade-off between precision and recall across different decision thresholds. So this graphic showing how we buy the data from the input to the output. So we collect the data from the website and then clean them a bit. And for text, we do, for the experiment of text, we do a few experiment vectorization, and then or not using fast text and neural network directly. We found out that the vectorization using TF-IDF is the best configuration for the text only. So in our experiment now, we only use, with regard to text, we only use that group of processing from sentence splitting, vectorization, and then TF-IDF, and then using TF-IDF to produce the text vector. So for image vectorization, we take state-of-the-art image feature extraction, like the NASNet last, NASNet mobile, then 169 and ResNet 152 to produce the feature vector. And then after we have the feature vector, we combine them with the text vector and using attribute to perform machine learning on the classification task. So now let's talk more about the image feature extraction or image vectorization. So it turned out that deep convolutional neural network architecture can transform an image into a feature vector. Each of the vector is a vector that represents the whole image, typically for classification by the consumer model. It is a meaningful and compact summary of the image. And it turned out that the kind of information needed to distinguish between 1,000 classes in image is often also useful to distinguish between new kind of objects. And in our case, it's very useful in classifying the film into different rating certificates. And these days, this methodology is a kind of a very popular methodology to use in machine learning, and it is called transfer learning. So the image feature extraction models we have experiment with are the state of the art. And by state of the art, I mean state of the art when we submit the paper. And it could well be that today there's some new state of the art image feature extraction out there that we wouldn't know. So the different in there, in the image extraction model are the size of them and the internal structure. For example, the DEN 169 is the densely connected different layer, whereas the Inception V3 is an efficient implementation of ResNet, which itself is residual next a revolutionary. So the residual next paper, I think that is the most cited paper out there. It's only maybe 5 or 6 years ago, but it feels so old by now. And then we have the network NASNet. NASNet is the network architecture. So basically, it relies on the computer to propose an architecture. And the accuracy range from 77 to 82% for top 1. With the top 5 accuracy, now we can get 96% accuracy top 5. So that's all about the data and the method. Now let's go to the resume. So for baseline, we have the majority class. We use majority class as a baseline, and the baseline for the US is 55% accuracy and 96% relax accuracy. For the UK, 45 and 73%. It should be noted for relax evaluation, the majority class is different from the exact accuracy, because if we use PG13, then they are more of PG13 and PG and R than the R and PG13 and the NC17. So that's why they are different. So this is the result from our experiment from using only image feature, using only text feature, and using the combination of text and image feature. So as we can see here, that say the image alone already surpass the baseline. And this is significant because what we have is only image from represent a sample of image. We fully rely on IMDb to collect the image of the film, not the film itself. But it already get to around 64% accuracy for the US and 56% accuracy for the UK certificate prediction, which is fairly good. And then we have, with the text only feature, we get 79% for the US and 65% for the UK. When we combine image with text, we get better, but only ever slightly. Still, the improvement is statistically significant. It may not be practically significant. So it's like we can get 2 more classification correctly classified correctly classify for every 100 title. But regardless, we can see that the image vector do add a little bit of information to the classification model. And if we look at the upper ceiling of the problem, which we use the UK classification to predict the US classification, or we use the US classification to predict the UK, or we use all the certificate from every other country to predict a single country. We say that 84 and 80% are the selling of the prediction. And as very soon we can see that for the US we are getting close to the selling, but from the UK there's a lot of room for improvement. So here we have a graph to show how the accuracy improve across the different settings from the US, from UK to the US, and it show that using text embedding is not a good. It also a good using the image alone, where we need to use the engram to get very good result, and when we combine with image, we get slightly better result. So here we example of image classification using the image alone to classify image. And so I think that's it's my time up now.
Yes, yes,
okay.
Exactly. You finished on time.
Okay.
Thank you,
yes.
Dr. Lia. And this is very interesting. If there are any questions?
Hi, can I ask a question?
Yeah, sure, absolutely.
Yes,
Dr. Leha, it was wonderful presentation. Thank you for presenting such a nice work. And my question is, if I correctly remember, you said you are using film scripts as well, right?
Film script, yeah, film script, yeah.
But the thing is, if the film is not released yet, and I believe that they don't release the scripts yet, so how we can rate those movies without having the scripts available?
So I think we yet to think about the end application of the model, but they believe it like this. Say the author submit the script, and then the machine read the script and say, oh, this is PG-13. And then the author saying, oh, I want my movie to be PG. Then they can somehow change something in the script so that the model are happy that okay, this now the script is better.
Yeah, I understood that. But if the movie is releasing in the next week and I don't have script, but I have to tell my kids whether this is okay for you to go or not.
Oh, so I mean, saying for that we need to talk to the producer, and we need to present the producer with this, and we say, look, there's a question here, and there's a lot of people who say, why don't we have a fair machine model to suggest to determine which film is appropriate or not, instead of somebody just decided and so on. But otherwise, I don't think we have any other solution for your question.
I can understand, because I don't think that people will reveal the story before releasing the movie. Yeah.
Yes, that's quite true. So that's another thing. Let's say we can convince the producer that say you can release the script to a machine. It won't. So nobody. So it will suggest the certificate but without actually making the film less interesting.
Yeah. Thank you very much. Thank you very much.
Yeah, you're welcome.
thank you. So is there any other question? Any other question? Thank you, Professor Beha. And we will.
Yeah, thank you very much for attending the presentation.
It is our honor and pleasure. Third one is SDSV angle measurement for supervised classification. So is the presenter available? I think Anik is the.
Yeah. Hello.
Okay. Yes, Doctor. Yes.
Okay, I'm going to share my screen.
Yes, please.
Yeah, I hope my screen is visible, right?
It's visible. Thank you.
Okay, thank you. At first, I would like to give the thanks to the authority of SCNINGS and the session here for the given chance to present our paper. So today I would like to present the paper support directional shifting vector, which is an angle measurement supervised classification algorithm. So my name is MD Kowsher. I'm from Bangladesh, Noakhali Science and Technology University. And here is our motivations. At first, I'm going to talk about the motivation or why we decided to work with this algorithm. So we know in machine learning, classifications like a supervised learning algorithm plays an important role. And for such like in test classifications or other classification related to tasks. Different classification methods follow different techniques to map a target function to output. And this work has proposed an angle measurement based techniques called support directional shifting vector to segment a spectral domain into regions that have illustrated a very effective solution for an intelligence system. Okay, the primary object of this work are to introduce a state-of-the-art classification algorithm, and it can be also used various types of classification tasks. And here we solve various types of NLP related like the test classification problem. So in order to utilize the angle measurement techniques to classify linearly separable, this can be one type of solutions. And we use the most important things that we use here that non-parametric statistical learning, which we know the cosine similarity. We use the cosine similarity as a parametric learning, which is, and this is I think this is really most enjoyable to you. Okay, classifications such as like the test classifications in modern day is really been popular because every day we receive many emails. Among them, some of are useful for us, some of them not. Some companies, for example, send email frequently for their business purposes. That may not be useful for the users. So we need an intelligent system that can categorize the emails using classification algorithms and that mark the necessary email as spam. Therefore, machine learning algorithms have become very hot topic in the research community. Every day, many algorithms are being developed by researchers. If a researcher develops an algorithm, sometime later, the same algorithm can be modified by others. Okay, all of the methods have some advantages and disadvantages for a particular application. We know that, right? Here we propose a support directional shifting vector and advanced machine learning classifiers that deals with the classification problem with promising results. The SDVS work in this way, like that cosine, we measure the cosine similarity with the parametric way. But basically, cosine similarity can be used in most of the tasks as the non-parametric statistical learning. But here we make a solution of the cosine similarity that can be learned by parametric way. So, and it can be learned by the support directional vector and support origin vector. And at first, the two vectors are created randomly. Then it shifts and makes such a space for there where the accuracy is the best or the loss is the minimum. Okay, now comes to the support directional shifting vector. For a machine learning, for any machine learning problems, information like the information retrieval or text mining is one of the main tasks to be performed. Here two classes like that. Here we have to first generate the two class. If we have multiple class, then we need to make a target class, and other class will be the non-target class. And here is the first image of A. Here we have to make such a boundary that separate the target and non-target class. So this is a really simple solution. Here is our origin vector, and we need to create such a shifting vector. From the origin vector, the angle will be the minimum, or the relationship will be the maximum with respect to the target class, and the angle or relation. The angle will be the maximum, or the relationship will be minimum with respect to the non-target class. So at first we went through this solution, but there is a big problem. When the target class and non-target class like that are remaining in a such way like that parallel or like the such a defined line, then it will be obviously failure to separate the class. Here is the like that it cannot be separate the target class and non-target class by angle. Then we decided to move forward to shift also the origin, which is the origin shifting vector. So whenever we shifted the origin from O to O prime here, then it can make very easily relationship and make the maximum relationship with the target class and the maximum opposite directional to the non-target class. Okay, so mathematically, if we want to say that we can know the mathematical like that, in order to define the mathematical solution, we need a loss function. Here we use the categorical cross entropy, which is and we can also define our loss function like that. Whenever we consider about the target class, then the loss should be the 1 minus cos theta, and whenever we will decide the non-target class, the loss should be the 1 plus cos theta. Why you choose the like that? Because here cos theta means that cosine similarity that I already said. So if cos theta makes the maximum relationship like that 1, then the loss will be the 0. If cos theta makes the relationship if the cos theta makes the relationship minimum 1 minus 1, which is the loss will be 0, which is our maximum relationship. We can also use the categorical cross entropy. If we also tested using the categorical entropy or binary cross entropy for the binary classification, and these losses are also working for the SDSV. And one thing is that here is the basic solution. Here is the if y prime is our prediction value. Then I just simply explain the notation of this one. Like that O prime is the shifting origin. Shifting origin means that the origin whenever it is shifted from O to O prime. So this is the shifting origin, and DI means that DI means the directional vector. In which direction we want to measurement. Like that, here is the directional vector, the green blue. Or if I say about the earlier image, here is the A is the directional vector. Okay, and O prime xi means that the samples data that we are using for the classifications, and in order to make the matrix multiplication, we just need the transpose of the x, and can easily make the matrix multiplications And whenever we will measure the angle between O prime and D prime with our testing data, then it makes the relationship very easy. Okay, now let's move to the training method. I think it will be very efficient for us. At first, the training method is that we need to select the input and output for the supervised learning. We know that, and in the first steps, we need to separate all the data points into two classes. That I already said that one will be the target class and the other will be the non-target class. And the target class should be the level as 1, and the non-target class should be the level as -1. Since the cosine similarity makes the relationship between +1 to -1, which is the range of the cosine similarity for all of the real numbers in as a domain. Okay, so randomly need to be the choose two support vectors for the origin and direction. We randomly choose two support vectors, then calculate the cosine similarity between the directional vector and all the data points from the origin vector that we already choose for the randomly. Scaling the calculated similarity to transfer the range 0 to 1 from 2. And one thing I forgot to say about that, if we use the categorical cross entropy or any kind of cross entropy, then we need to scale -1 to 1 as a 0 to -1. If we use the loss, this is then we can use easily it from -1 to +1. Okay, then we have to calculate the loss. We can calculate the loss using the gradient for the optimization. We know that, and then we need to update the two vectors, the origin and directional vectors. Then go to the step 3 and calculate the again cosine similarity, then update the loss. So we need to set up the two vectors such as origin and directional vectors such a place where the loss will be the minimum. Okay, here is the real life example. Then we took the pictures from the training of algorithms. So here is this is the point below is the shift origin vector, and this is the shifting vector or directional vector. So at the first epoch, it will make some more relationship than it is being trained. After the final epoch, it makes the relationship like that. So this is the shift origin vector, and this is the directional vector. So if a data points come like that x test 1, then it makes the maximum relationship, which is the angle minimum. If the point is here x test 2, then it will makes the maximum angle or minimum relationship according to the OD, which is the origin shifted vector. Okay, now experimental data set. So in order to experiment, we use various types of classification data. And since this is the assignment, that's why we propose two types of data set or related to NLP. One of is gender detection from Bangladesh. So, there is around 23K Bangladeshi name data set. And another data set is the topic classification, which is multi-level classification data set. And there are obviously 23 primary categories. Okay, so here is the result, and we use various types of existing popular machine learning algorithms. Here is RF means random forestry, SBM, net bias, and the logistic regression, KNN, decision tree, LDA, ANN, and SDSV. So for the gender detection from Bangladesh, we can analyze that the SDSV gives the maximum relationship of accuracy, which is around 89%, with the maximum F1 score, which is 87%. Okay, and we can also analyze the Hoque curve, and here is the random forestry, logistic regression, and SDSV are the maximum Hoque. And also, if we see about the coefficient kappa, and we can also the ANN and SDSV gives the maximum relationship of coefficient kappa. Okay, and this is the multi-class, which is a topic classification. Basically, this is the document classification of newspaper from newspaper, and there are 23 primary categories. And here we can also analyze that. Yes, LDA. Obviously, LDA gives the maximum accuracy, and the SDSV took the second position respect to in accuracy. And we can also say that LDA in the section of F1 score, LDA and SDSVs are the highest, and they are gives the more similar F1 score. And in order to consider the coefficient kappa, obviously ANN took the LDA took the maximum, and SDSV took the like that third level of coefficient kappa. Okay, and so we know that this is since this is new types of algorithms, and I think this is this we know all that cosine similarity obviously used for the non-parametric statistical learning. So we make the parametrical solution here. So support directional shifting vector, we know that which gives an outstanding performance compared to the other standard algorithm. And our approach introduced two vectors then, and one is support directional vector, and the other is support origin vector to measure the cosine similarity. And the starting point is that the two vectors are formed randomly and are shifted to another location until the loss considering with respect to the target class and non-target class, and which should be obviously minimum. And the origin vector is used to handle the any type of classification algorithms. So we also tested the PIMA Indian diabetes dataset and the other dataset like that wind prediction dataset from the table. So since the shifting vectors only consider the linear combination, the classification is performed linearly based on the angle. The nonlinear problems cannot be handled with these shifting vectors properly, and this is one kind of big limitation of this algorithm. But we plan to use a linear separation in nonlinear issue, considering another variable, and that we are calling the radius reduction on this step. So we already working to resolve this issue using the radius reduction on a step, and the radius reduction step will be the minimum radius on every separate step with the separate values. So in the future, we have planned to develop the nonlinear solution that is our limitation for now. And we have also planned to execute or develop a Python-based API using the PyTorch so that everyone can use just call in the API. Okay, so if you have any questions, please feel free to ask me, and I will be happy to answer you.
Thank you very much. We have we can take one question. So okay. Thank you very much. Let us good whether we are running out of time.
Dr. Khaled.
Yes.
Thank you. I need to ask the presenter about the multi-classification problem. Proposed work as a vector direction.
Okay, basically, if I can analyze in this figure, we need to create such a directional vector like that. Here is the OD. If we can create the OD, we can easily measure angle with the target class and non-target class according with respect to OD, like that, which is a directional vector. And this can be done easily the cosine similarity. Consequently, we use the cosine similarity here.
Do you think there is any limitation about this scenario? If we go to look at the huge number of classes.
Mhm. Yes, you are asking about the number of class. Obviously, this may be the, I already said that whenever we have multiple number of class, then we need to take one class as a target class and other class will be obviously the non-target class. Then it need to make a Hossain similarity for a specific the target class. Whenever we will consider the second target class, and we will the first target class will be also in the group of non-target class. Then we will make the Hossain similarity for the second class. That's why we can. That's why we use the topic classification, which is a multi-class of problems. And I already said that there is 23 categories, primary categories.
Second comment about the Kappa formula. That when you go to look at the table we received, the Kappa is the precondition. It's if you have more than 0.7, it's good as accuracy. Within your evaluation within Kappa here, you have under 50% with the naive base. What you mean by this value? It's reasonable.
Okay, I didn't get you properly. Could you please repeat the question again?
Yes, the Kappa algorithm, if you have the accuracy of Kappa, we have precondition. The value to accept it must be more than 70%. This is the point. Within the NB, you have the other values. It's reasonable, but within Kappa, it's very low. Look at this scenario. We have some adjustment here to discuss it in your future work, please.
Okay, you are asking about the coefficient kappa?
Yes, yes, of course. Yeah.
Okay, I think the coefficient kappa is really depends on the data set. Like that, there are lots of data set and the coefficient kappa is really low, but the accuracy is really fine. So this is one of kind of a statistical measurement, and every statistical measurement have its one way to measure the result.
Yeah. Okay.
I think yes.
Good luck, inshallah.
Thank you very much. Thank you very much. Next one is because we are running out of time. Is feature rich classifier for recording textual entailment in Indonesian by Rani and Shnian and Wave and so on. I think I have the recording. I think. So would you like me, Rani, to run the recording and you are available for discussion after it?
Yes, sir. Please just play the recording that I've sent.
Okay. I will share your video. Okay.
Good afternoon, ladies and gentlemen. My name is Rani Aulia Hidayat from Faculty of Computer Science, Universitas Indonesia. In this occasion, I representing my colleagues Isnainur Hasana, Wafa Karisa Putri, and Rahmat Mahendra are going to present our research entitled Feature-Rich Classifiers for Recognizing Textual Entailment in Indonesian. This presentation consists of 4 parts. First, we are going to tell you about the background and literature of the research in the introduction. Second, we will explain about the methodology of this research. Next, we are going to show the result and evaluation from the experiments we conducted. And last but not least, we will end the presentation with conclusion. Let's start with the introduction. A text can contain information that can be inferred into sentences. The inferred sentences can carry information that is in accordance or contradicts with the text. Recognizing textual entailment, which also known as natural language inference, is a task in natural language processing that aims to determine the semantic relation between a pair of 2 sentences, which commonly named as text T and hypothesis H. RTE, or Recognizing Textual Entailment, is helpful for other NLP tasks such as question answering, information extraction, information retrieval, and also credibility assessment tasks. Various approaches have been proposed by researchers to accomplish the RTE task, including the feature-based approach that uses rich features to determine the entailment relationship between a pair of T and H. In 2015, Bowman et al. Implemented 3 lexicalized and 3 unlexicalized features on Stanford Natural Language Inference Dataset, or SNLI. While in 2018, there was also a study that used a total of 35 features to match NLI dataset. While in our work, we aim to design a feature-rich classifier model to determine the entailment relation between sentences in Indonesian. A few work of RTE tasks in Indonesian include in RTE, in and rate. The InRTE is a dataset that being developed using an initial 400 question-answer pairs, while RED, in its original paper, they employed LSTM to 1,857 new label data from co-training algorithm. It achieved an accuracy of 76%. The Indonesian benchmark for natural language understanding tasks, or Indo-NLU, also used RED dataset for its experiment with the Indonesian bird, or Indo-bird. It resulted the highest F1 score for the experiment is 84.17 out of 100 using Indo-bird large. Next, we will explain about the methodology. This research is conducted in several phases. First, we collect the data. Then we preprocess the data before the feature engineering phase. In the classification phase, we also perform an ablation study. And finally, we evaluate the result from the classification phase. For the data that we use in this research is RED dataset that originated from the Indonesian Wikipedia articles and revision history. And since the RED dataset is also used in the Indo-NLU, the data split that we use in this research was based on the RT experiment in Indo-NLU. This dataset consists of 2 classes, which are entail class and not entail. The entail class refers to the entailment relation between text T and hypothesis H, while the not entail class refers to the contradiction or no semantic relation between text T and hypothesis H. In this research, we did not use the validation set. As we can see here on the slide, the training data consists of 183 pairs of entail class and 117 pairs of not entail class. And for the testing data, it consists of 61 pairs of entail class and 39 pairs of not entail class. For the preprocessing phase, we use NLTK and Sastrawi on Python. The steps on preprocessing are delete spaces exist before and after any word, or also known as white space removal. We also change all text in T and H to lower cases, delete any punctuations and special characters. We also change all words in T and H to their roots, or also known as stemming, and delete words that exist in the stop words list. In the feature engineering phase, we extracted 35 features that group into 5 categories, which are distance-based features, token-based features, post-tag features, negation features, and blue score features. The first group of the features is the distance-based features. It consists of 4 features that extracted from the preprocessed T and H. The features are: first, word movers distance is being calculated based on the word-to-vec pre-trained word embedding. There is also Levenstein distance. Jacob similarity, and Euclidean distance. There are 9 features in total extracted in the token-based categories. The first is the ratio of similar tokens and difference number of tokens. These two features is calculated based on both the raw and the preprocessed T and H. And then for the number of tokens, it's calculated based on the preprocessed T and H. For number of overlap unigrams and number of overlap bigrams, it's being calculated based on the raw T and H. And for L2 norm, it's being calculated based on the bigrams in H. The third category is post-tag features. We extracted a total of 3 features from this category, which are the number of similar post-tag between the raw T and H, then the numbers of same pair of post-tag and token, or we also can call it as a full match. It's being calculated based on the preprocessed T and H. And then we also calculated the percentage of the same pair of post-tag and token from the preprocessed T and H. There are 15 features extracted in the negation features categories. In here, we use 5 negation words in Indonesian, which are tidak, belum, tak, bukan, and jangan. And from each negation words, we calculate the number of occurrence in T and the number of occurrence of each negation words in H. We also calculate the difference number of each negation words in raw T and H. The last group of feature is blue score features, which consists of 4 features which are being calculated based on the unigram, bigram, trigram, and quadragram of the preprocessed T and H. After we done the feature engineering phase, we experiment with 3 different supervised classifiers, which are support vector machine, logistic regression, and multilayer perceptron. For the support vector machine, we use the radial basis function for the kernel, and for both logistic regression and the multilayer perceptron, we set the maximum iteration to 1000. In the next section, we will present the result, and in addition to the accuracy-based metrics, we also analyze the computational time and size of each model. We also perform an ablation study to see the importance of each feature groups. Next is the result and evaluation. In the first experiments, we employed all groups of features to evaluate which classifiers that give the best performance. The result of each model will be used as the baseline for the experiment and the ablation study. Here we can see that the best model is support vector machine with an F1 score 79.65%. We can see that all models have the same size, which is 64 bytes. And for SVM, it has the fastest turning time, while the prediction time is a bit slower than the other models. In the second experiment, we conducted an ablation study. The scenario is we remove each group of features one by one and evaluate it by the F1 score. Here we can see when we use the support vector machine and the logistic regression, the most significant change occurred when we remove the token-based features. Here, for the support vector machine and the logistic regressions, the F1 score decreased for more than 3%. When we remove the token-based features. While when we use the multilayer perceptrons, the most significant change happened when we remove the post-tag features. The F1 score decreased for more than 2%. And we can also see here from the table that When we use superfactor machine, then we remove distance base or negation base or blue score base features. It does not give any impact to the F1 score. While for the logistic regression, when we remove the blue score, it does not give any impact to the F1 score. But when we use the multi-layer perceptrons, any removal of the features will be impacted to the F1 score. So here we can say that for superfactor machine and the logistic regression, the most important features is token-based features. While for the multi-layer perceptron, the most important features is post-tag features. As mentioned before, since the dataset that we use is also being used in the Indonesia paper, we compare our result from the first experiment that used superfactor machine to the best result in Indonesia, which used Indo-BERT large. Here we can see, even though the F1 score of our classifier is 5 points smaller than the best score in Indonesia, we can see that the training time of our classifier is much more economical compared to the Indo-BERT large. So we can say here that our proposed classifier is pretty competitive compared to the benchmark in Indonesian language. We also try to analyze the example of the result from the model that incorporated all features using superfactor machine. So here for the first pair, it's being misclassified as not Intel. And actually, the difference in the text and the hypothesis is only on lexical level. So on the text, in English, it says that the air transportation is being provided by Ngurah Rai International Airport with destination to some big cities in Indonesia, Australia, Singapore, Malaysia, Thailand, and Japan. While in hypothesis, in English, it says that the air transportation is being provided by Ngurah Rai International Airport. And for the second pair here, is being misclassified as Intel class. And actually, there is just one different word from texty and hypothesis. So the difference is on the word Indonesia and Melayu. So here from the dataset, actually there were not too many pairs of T and H in the dataset, so there are still no significant difference between text T and H. And it also affected how the model learns to classify the entailment class from a pair of sentences. In conclusion, this research is about features classifiers for recognizing textual entailment in Indonesian, which used in total 35 features that group into 5 categories. We used 3 different classifiers, which are superfactor machine, logistic regressions, and multi-layer perceptrons. We also conducted an Bayesian study to analyze which group of features is the most impactful. The token-based features positively contribute to the performance of the models that use superfactor machine and logistic regression, while the most significant group of features when using multi-layer perceptron is post-tag features. One of the best performance is obtained when using SVM with all groups of features. It resulted in F1 score of 79.6%. And even though the F1 score of our proposed method is lower than the F1 score in the benchmark paper, our proposed method has a much faster training time. Here we also recommend to introduce ledger data to benchmark RTE tasks in Indonesia to test the model in more reliable setting. It brings us to the end of the presentation. If there is any question, we will be glad to answer any of it. Thank you.
Thank you very much. I think I saw one hand raised. Please, Professor Hossain.
Yes, thank you very much about your work. This is for related to master degree or PhD degree, please.
Sorry, can you repeat the question?
This is master degree or doctoral degree?
It's for master degree, Mr. Hassan.
Okay, I agree. It's a great work, inshallah. But I need to ask you, and the first comment, it's related to the data you had, the balanced data. Can you work with balanced data to equalize between the two classes you had?
Yes, actually, my colleague and I expected to work to another data, since the data set that we use now is just small data set that only consists about 400 pairs. And we would like to try to another data set to prove that our proposed method is can be more reliable.
Yes. Second comment is related to the negation. Can you, as an example, maybe you use around 5 negation words, Indonesian word. Can you translate it into English, please?
Okay. Okay, for the negation words, the first is tidak. In English, it means like no. And the second one is belum. It means not yet. And the third one is tak. Actually, tak and tidak has the same meaning. It also means no. And the fourth is bukan. Bukan means it actually refers to like some things. For example, it is not a pencil. It's the same as bukan. And the last one is jangan. Jangan means do not in English.
Thank you. Thank you.
Answers. Yeah. Thank you, Mr. Hassan.
Thank you very much, Rani, and good luck. Let us take the last one. I think Marwan is going to.
Hello, everyone. Are you hearing me?
Yes. Covariance pooling layer for text classification by Mai Ibrahim, Ayman Shawat, and Marwan Turkey. I see only Marwan is connected, so Marwan is going to present.
Okay, hello everybody. I am Marwan Turkey. I'm an associate professor at Alexandria University.
Welcome.
Yeah, and this work was done by my former master students Mai Ibrahim and my former bachelor student Ayman Shawat. So I'm going to introduce this work, which is title is Covariance Pooling Layer for Text Classification. So this is our agenda. We will start with very brief introduction about the problem we are solving. We are solving text classification problem. And I will describe the CNN, convolution neural networks for classification. Then I will introduce the use of the covariance pooling layer inside the architecture, and then we'll discuss model complexity. And finally, I will share the results with you. For the text classification problem, it is a very traditional problem in natural language processing, where you have documents, paragraphs, tweets, any kind of text, and you'd like to classify them into different class labels. So, for example, you have mixed data set like this on the left, and then you try to make a model that can separate a positive, negative class or multiple classes if you are dealing with a multi-class classification problem. So the traditional methods usually used bag of words representation or TF-IDF, and this is for a long time ago. Since 2013, maybe the word embedding appeared, and the word2vec, fast text, glove embeddings were dominating at this point of time. And later, the convolutional neural networks that were doing a perfect job in image classification, it was introduced to work with word embeddings to do the text classification. Later, recently, there are many models using transformers networks for text classification. So this is a brief introduction about the problem itself. Our solution is working using the same methodology that is used in using convolutional neural networks for text classification. So what about the convolutional neural network for text classification? The convolutional neural networks consists of mainly 3 layers. The first one is a convolution layer, the second one is a pooling layer, the third one is the classification or the fully connected layer. So our contribution is mainly in the pooling layer here, where we, instead of using just max pooling or average pooling, we use a covariance pooling layer. And this is our contribution. So what is the covariance? The covariance is the second order summary statistics for two random variables. You can compute the covariance using this equation. Supposedly we have d random variables, then we can build a covariance matrix. So where are these d coming from in our configuration? Since we are using word embedding to represent words, every word is represented in d dimensions. So that is a d. So to make things more clear, I will go over the model architecture, starting from the document. The document has many words. Every word has d dimensions. So for example, this is a sample sequence, and it means that the input text, supposedly coming from a sentence or coming from a document, is represented as a sentence matrix. So the sentence matrix, it has rows, which are the words, and it has columns, which are the dimensions. And we are using a d-dimensional vector to represent every word as in the sentence matrix. Next, so this is the representation of the document or the sentence. So the convolution layers, it applies many convolutional filters, many convolution filters, many kernels on this sentence matrix, and every filter will produce a vector of size 1. And since we have m convolutional filters, we will have at the very end m convolutional features. So it means that we are transforming the data from d features into m features. So this is the convolution layer. So this is the first step in the architecture. The second step is to apply the pooling. So the pooling, the regular pooling is down, the max pooling. From every feature, you extract the maximum element or maybe the average element. It's up to your design. But using the covariance pooling, we have these convolution features of m dimensions. We can compute an m by m matrix using the covariance equations, like this matrix. And once you have this matrix, you have an m by m features. So what is contained in this m by m features? Every element is computing the covariance between this element. Say C11 means you are computing the covariance between this feature vector and and the same feature vector again. But C12 is that you are computing the covariance between this vector, the blue vector, and the green vector, and so on. Once you have this matrix full, this is extracted features from the convolution features. The next is to go for the classification layer. You have either the traditional option using max pooling, and you go through the hidden layer and then the output layer, or you flatten this covariance matrix into m squared element and go for the classification. And also there is an option which is concatenating both features coming from the covariance and coming from the max pooling. So in our study, we studied the three options using the max pooling, traditional max pooling, using the covariance pooling, and using the concatenation between these features. So the full architecture here, we start with a sentence matrix, compute convolutional features using kernels, and then we do the covariance matrix or max pooling, and then we flatten this covariance matrix and concatenate it with the max pooled features, or without concatenation, then go to the hidden layer and go for the output layer for the classification. The model complexity, because we are introducing a new term here, which is the covariance matrix computation. So the model complexity, we start with the convolution layer complexity. If we have k kernels and we have m kernels with k width. Every one has k widths, and we have originally d dimensions. This is mainly the main complexity of the model, because for example, d is equal to k, 1 over 2 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 k, 1 over
Sound, we can't hear you, please. Sound.
Hello? Can you hear me now?
Yes.
Okay. So what I'm saying is this, the model complexity, it composed of three terms. The first term for the convolution, the second term for the covariance pooling, the third term for the classification layer. For the convolution layers, since we have d dimensions, d dimension, usually d is large, 300 or so, like most of the word embedding models. We have m, which is the number of kernels, which is a little bit smaller than d. We usually use something around 32 or 64 in our experiments. So even if we added m squared times h, it is still much lower than this term. Okay, so the main complexity comes from the convolutional, not coming from the covariance. As long as we keep m small, but if we enlarge it n, something like 100, 200, 300, something like this will add more complexity to our model. Okay. In our experiments, we studied different values for m, different values for k, different values for h, and we reported our best results. So we used 10 different text classification data sets. Some of them were binary classification problems. We have two classes only, and this is like the IMDb for movie reviews, customer reviews, another movie review data set, subjectivity data set. And we have also tested on the multi-class classification data sets. We have also 6 of them. So in total, we have 10 data sets. We followed the same procedure for every data set. It is very common to use cross-validation in movie reviews and subjectivity analysis and customer reviews. And in some data sets like IMDb and the Trek, the test data is well defined by the authors of the data sets. So we use the same procedures that are usually used. So we had one thing to consider, which word embedding was better for us. We tried 3 different word embeddings on the IMDb dataset for movie review classification. We used the glove embedding, we used the Word2Vec, we used fast text, and we found that glove was doing a better job in this classification task. And we found that the covariance pooling using glove was doing better than max pooling, and the concatenation, oh, I'm sorry, this is not the best. The covariance pooling was the best in this dataset. I'm sorry for this mistake. Okay. And also we reported our results on 10, on the other 9 datasets. We used the glove embedding because we found the glove embedding is doing better in IMDb, and then we used it in the other 9 datasets. So these are some competitive approaches. Some of them are using covariance features, but on very small set of data sets. They were not using it as a in convolution neural network, but it was just extracting the features and feed them to a supervised machine model. Another model was using kernel SVMs like Gaussian distribution, and some other mover distance and supervised mover distances were used on this same data sets. The traditional max pooling was reported. The covariance pooling is also reported, and the concatenation between these max pooling and the covariance pooling. Covariance pooling, which is reporting 98.8, is the best over a Trek dataset, and there is no reported results all over the world better than this number. So this is the covariance pooling is getting the best result on this Trek dataset. And in general, if we look at the last column, we found in the covariance pooling is a better way of pooling for convolution neural networks in text classification in over in 10 data sets for text classification. So we use the covariance pooling layer with convolution neural networks to improve text classification tasks, but still we can use covariance pooling on other tasks more than text classification. We can introduce some enhancements to our model because we are just using covariance pooling without waiting, or we can apply some attention mechanism on this to improve covariance pooling. And also we can try to handle the issue of the complexity of M, because if we use the M large, M squared, it will be larger. So we can introduce something like K-max covariance pooling instead of flattening the whole M by M matrix. We can just keep the first highest K element or something like K-max pooling. And also we used the covariance pooling with the convolution features, but we might try in the future to attach the covariance pooling layer to other transformer based architectures. This is my presentation. I am ready for questions.
Thank you, Professor Marwan Turki, and we are. This is the last, so we can take a couple of questions. Any questions, please?
Yes, Dr. Khalid, it's just a comment to ask Dr. Marwan about
Yes,
something, please.
Yes, sure.
Do you think that we can use this methodology within machine translation model to work with RCNN?
Actually, I had some other experiments in other work where we used the covariance pooling after a recurrent after a recurrence layer. So instead of using convolution, we used the LSTM or GRU in the first layer to do the dimensionality reduction. So the problem with the convolution with our model that we know of is that if you have D dimensions and then you are computing matrix D like 300, then the covariance will be 300 by 300 from the very beginning. So the covariance can work well if you have a small number of dimensions. And we can do this either by using convolution like we did in this work, or we can do that the same way, but instead of using convolution, we can use recurrent layer like LSTM or GRU. So, but I didn't use it in machine translation yet. I used it in other application using recurrent as a feature encoder.
Yes, this is a point. Thank you, Dr. Marwan.
You are very much welcome.
Okay. Thank you. Is there any question? Any question?
We have time, Dr. Khalid.
We finished with, we will start the break now for 20 minutes.
Okay, okay. No, it's a break. So go ahead.
Okay.
Go ahead, please.
You can, we have rooms, so you can have continued discussions. This is what we, or during break. There's no problem. Thank you very much. And
thank you, Professor Khalid.
Thank you very much. Let us go to break for 20 minutes and then come back for the next session, parallel session. Thank you.
So will we get the records for the
Inshallah.
Okay, thank you very much. Thank you.
Inshallah. We have also a YouTube channel. You are going to
Okay, great.
Thank you. Thank you. Salam.
Alaikum salam.